Hi everyone, welcome to the video. Today we are going to solve pairs violating the binary search tree property, BST property. So before we begin, we first understand what are the BST properties that we must not violate. The first is every node is greater than its left child and less than its right child, which means for a given root, it will always be always be greater than its left subtree, left child, and smaller than its right child. I will repeat again. For every root, it must be greater than its left child and smaller than its right child. One. Second, so every node is greater than the maximum value on its left subtree and less than minimum value of its in its right subtree. That's the same similar thing which I said. But the most important thing is the maximum in the left subtree, maximum node in the left subtree must be less than the minimum in the right subtree, which means out of n number of nodes in the left subtree, the maximum of those nodes will always be less than the minimum on the right subtree nodes. So how? Let's see. In example one, we are given this tree with five number of nodes. Okay, and we have to return the pairs which are violating the BST properties which we discussed. So as you can see this 10, 50, 40 initial one. As we know that root should always be less than the right and more than its left subtree, but here everything is opposite. As you can see, 10 should be less than 50, but it is not the case. Then it is violating. Then 10 should be less than 40. Okay, that's fine. Root can be less than, that's fine. Then 1050 is one such pair. Then 40 and this 30, again it's violated because right child is 30 and root is 40, and root should always be less than the right subtree, right child, two pairs. Then as we can see this 50 and 20, because the third point which we discussed, the maximum element in the left subtree, which is 50 over here, should always be less than minimum in the right subtree, should always be less than minimum in the right subtree, and minimum in the right subtree is 20 and maximum in the left subtree is 50. So it would have been, if it would have been correct, then 50 should always be less than 20. But that's not the case. In this case, it will violate all three: 50, 20, 50, 40, and 50, 30. All three will get violated. So hence total five such pairs are getting violated. See, example 2 is also similar. See, 80, 30. 80 should be root should be less than the right side, which is not the case. Violating. Okay, cool. Then 80 and 60. 80 and 60. That's also not the case. Root should be less than all the elements in its right subtree. Okay, again, then 80 and 70. Root should be less than all the elements in the right subtree. Then 80 30, 80 60, and 80 70. They are getting violated. They are getting violated. There again, look at the minimum number in the right subtree, which is 30. And what is the maximum number in the left subtree, which is 70. 70 should have been always less than the 30, but it is not the case mathematically. Then 70 will produce an error, or we can say this this 30 will produce an error. This 40 30 will produce an error. Okay, 40 30 will always produce an error. Cool. So let's see how we can do. In order to do this question, you need two steps. So as we know in binary search tree, if we list down all the elements in the BST, it will come in a array manner, sorted array manner, because they follow binary search property. So we will do in order traversal. We will do in order traversal in this in the given tree, in the given binary tree, and we will find the array representation of this binary tree, and then we will check what is the number of swaps we require to make them in a sorted order. Then first of all we'll do in order traversal, and then we will find out the array representation of this binary tree, and then we will find the number of swaps we need to sort this array, because binary search trees representation array should always be in sorted order. And when this will not come in sorted order, we will see the number of variations, number of swaps we required to make the arrays sorted. And in this case, we will get the answer. Of course, there are other method also, but this is the easiest and simplest way, and you can understand it very effectively because inner traversal is pretty basic algorithm, and then sorting is very basic algorithm. So you can use any of the sorting approach, but I will use merge sort in order to get the least time complexity. Cool. Now coming back, first I created an in order method which takes input, which takes parameter node. Okay. Now if not node, which means we are at the leaf node. In that case, we will return, come out of the loop. Then in order traversal is left, data, and right. So first we will recursively call the left side, then we'll append this data, node dot data in this in array. In array is the in order representation of this given binary tree, and then again we will call this right side of the tree. So as we know, in order traversal is simply left side, data, and the right side. Coming out of the loop, we will call it by passing the parameter as this root, and we'll create a variable result. This result will give us the answer, which is the number of variations or the number of swaps we require to sort the array. Both will be same. So first I will create a function merge which will take array. Cool. Then I will create a non-local result variable because I don't want to override it as of now. So if length of all array is less than or equal to 1, which means it is already sorted. If it is 1, it is already sorted, and if it is less than 1, then there's no need to sort. We'll just return the array. Then I will create half, find the half of uh, the array, and I will break into two parts and sort them, recursively. But first part and then second part. Cool. We divided the array into two parts. We will sort them, okay, one by one. First of all, three variables, ij and answer. So ij are simply iterators, and answer will be the number of variations in this step. Okay, let me make it some. Now coming back, so first we'll check while I is less than length of a and j is less than length of a, which means we are within the specified bounds. So if everything is going correct, hunky dory, then ai, if ai is less than bj, if a of I is less than b of j, then everything is good. It is already in sorted order. Answer dot append a of I is the correct order because ai is less than, so we appended it. Okay, and incremented I with 1. But if that's not the case, which means we have found a variation, which means this, according to the correct structure, if it is sorted, if the array elements are in sorted order, the left side element should be less than the right side element, which was the case in the if condition. But if is not true, which means else will get true, which means the right side element is smaller than the left side element. Element in the right side of the array is less than the element in the left side of the array. Okay, we have found this is the case here. The maximum in the left subtree must be less than the minimum in the right subtree. So this is very important, very beautiful question in which you are solving question on based on tree using the merge sort arrays, which is very amazing. Okay, so then again, if we have found the variation, which means how many swaps we will require, the total number of length which is remaining in the left side. Okay, total number of elements which are there, the remaining elements in the left side, which is A. Okay, and answer will append this B of J. Increment J by 1. Cool. Now, after we have found all the invariations or number of steps required to sort the array, okay, we'll check if I is still less than length of A, the left side, smaller side, then the answer will extend the, the left side. And if you don't know what is extend and how it is different than the append method, then extend does the same job as append does, but with a catch that if you are, you know, if there is one list or any list or iterator, any other iterator, sorry, iterables, such as let's say tuple also, if you are appending the other one, it will it will get appended as an entire different iterable, which will, like, if you are appending list with another list, it will come inside list inside another list. Okay, but using extend, it will be just one list, and the elements will come in the array, the first array, in the first list. If you want to explore more, there is always a better answer and more detailed blog in the GFG Geeks for Geeks. You can go through it. Then again, if J is less than length of B, similar thing, answer will extend this right part. Cool. At the end, we will return our answer. We'll return our answer. Okay. Now we have come out of the loop, and we will call our merge sort function with the in array which we define, and at the end we will return the result. Result stores the number of variations, number of swaps required to sort the array. And as you can see, it did the job pretty effortlessly and need very less time. So I hope you learned this beautiful concept and enjoyed it. Thank you. Have a very nice day.